Hello, this is Andrea Hendricks. The topic of this video is Section 4.5 homework problems, specifically dealing with equations and inequalities. I have created another video to deal with the application problems that you will have. So the first problem from my math lab is to use this calculator-generated graph to find the solutions of the given equation and inequalities. It is to solve the square root of x plus 7 is equal to x plus 1. Well, to do that, we would need to find the point where those two graphs intersect. You'll recognize the square root of x plus 7 to be this radical equation, and x plus 1 is a graph of the line. So whenever I'm looking at where they are equal, I find this point of intersection, which I'm actually told, which is 2, 3. So the answer to the first part is where x is equal to 2 and y is equal to 3. But understand, if it said just state the solution of this equation, it would only be the value of x, which would be the solution set of 2. Now the other two parts to this graph, which you don't see here, are to solve where the square root of x plus 7 is less than or equal to x plus 1, and the square root of x plus 7 is greater than or equal to x plus 1. So the square root of x plus 7 is less than or equal to x plus 1 means to find the pieces of x where the radical equation is below the line. And that happens to the right of 3. So that would be from 2 to infinity. Did I say from the right of 3? The right of 2. The square root of x plus 7 is greater than or equal to x plus 1 is where the radical graph is above the line. Well, that happens only for where the radical is defined, and that is from negative 7 to 2. In other words, I cannot just say negative infinity to 2, because in so doing I would include values for x that are restricted for this radical. In fact, if I want to find specifically where the square root of x plus 7 is defined, I have to set x plus 7 to be greater than or equal to 0, where x is greater than or equal to negative 7. So the answers to either one of these inequalities can only include values that are from negative 7 to infinity. In other words, subsets of that. Now, number 2 that I have selected to work is actually number 3 in my math lab. It's to solve this equation, square root of 3x plus 2 equals 3. It's already in the form we need, so we just have to square both sides. And when we square the square root of 3x plus 2, we just get what? Yeah, 3x plus 2. And that's equal to the square of 3, which is 9. So solving for x, we subtract 2 to get 3x equals 7, or x is 7/3. And if we check that, we plug into the original equation in place of x the value 7/3 and determine if we get a true statement. Well, 3 times 7/3 is just 7, and 7 plus 2 is 9, and the square root of 9 does equal 3, so 7/3 is the right solution set. Now, number 5 in my math lab is to solve the square root of 15x plus 40 plus 2 equals 3x. It's not in the right form, so what we have to do is isolate the radical expression by subtracting the 2 from both sides. So we get the square root of 15x plus 40 equals 3x minus 2. Now with the radical isolated, we can square both sides to eliminate the radical. And in doing that, the square of the square root just leaves us 15x plus 40. And be careful on the right, when we square the binomial, we will get a trinomial. And make sure you follow that. We square 3x to get 9x squared. We double the product of the terms to get negative 12x, and square the last, which is always a positive. Now we have a quadratic equation, so we have to set one side to 0. We subtract 15x from the negative 12x to get negative 27x. Subtract 40 from 4 to give us a minus 36. And a beautiful thing about this equation is that 9 is a common factor, so we can reduce it down to get 0 equals x squared minus 3x minus 4. And it does factor nicely. The factors of 4, whose difference is 3, would be 4 and 1. Different signs, larger one being negative. So x minus 4 is equal to 0, or x plus 1 is equal to 0. So our two possible solutions are 4 or negative 1. Now we check. We plug in the 4, does that check? So is 15 times 4 plus 40 in the square root plus 2 equal to 3 times 4? Well, what is that? 60 plus 40 is the square root of 100, which is 10, and 10 plus 2 does equal 12, so that checks. If we plug in negative 1, we get what? Negative 15 plus 40 is the square root of 25, which is 5. Does 5 plus 2 equal negative 3? No, it does not. So the only solution is 4. The next few I've selected from the book. It is to begin by drawing a rough sketch to determine the number of real solutions to the equation y1 equals y2, and then use an analytic method to confirm your answer. Give the solution set and any extraneous solutions or values that may occur. So let's look at number 7. If we have the square root of x, just a rough sketch, we know that the square root of x is something like this, right? Now, what about the negative x plus 3? Well, that has a y-intercept of 3, and the slope is negative 1, so we would begin at the y-intercept of 0, 3, down 1 over 1, and continue in that pattern. So we see that there is a solution. The value of x where those two graphs meet. So to do it analytically, we would have to say is the square root of x equal negative x plus 3. And since the radical is isolated, we can square both sides. So we would get x is equal to, when we square the negative x, we get an x squared. Doubling the product gives us minus 6x plus 9. So setting that to 0, we get x squared equals, 0 equals x squared minus 7x plus 9. Unfortunately, this equation does not factor, so I've got to use a quadratic formula. Write x is equal to the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. Hopefully that's ingrained in you pretty well by now. So we would have x is equal to the opposite of negative 7, which is just positive 7, plus or minus the square root of negative 7 squared, which is 49, minus 4 times 1 times 9. And that's all over 2 times a, or 2 times 1, which is 2. So we have that the solutions to this equation are 7 plus or minus the square root of 49 minus 36, which is 13, over 2. So one solution is 7 plus the square root of 13 over 2, and 7 minus the square root of 13 over 2. Now if we were just solving the quadratic equation, we would be done there, but we're not. We're solving a radical equation. So we have to check to see which one makes that true. I suggest that you just, for now, approximate those solutions. 7 plus the square root of 13 divided by 2 is 5.3, and 7 minus the square root of 13 divided by 2 is 1.697. You know what, so let's just call that, for the purpose of this, 1.7 right now. So we're plugging in to the original problem, is the square root of 5.3 equal to negative 5.3 plus 3? Well, the square root of 5.3 is 2.3. Is 2.3 equal to negative 2.3? No, so that one does not check out. If we plug in 1.7, is the square root of 1.7 equal to negative 1.7 plus 3? Well, the square root of 1.7, now remember we've also approximated, so we're going to probably be slightly off here, 1.3. Well, negative 1.7 plus 3 is 1.3, so that checks. So the solution to this equation is 7 minus the square root of 13 over 2. Now I want to work number 18 for you. This is one where you have the two radicals and you have to practice squaring the equation twice. So let's look at that here, part A. So if I have the square root of 2x minus 4 plus 2 is equal to the square root of 3x plus 4, when I square both sides, squaring the square root of 2x minus 4 gives me 2x minus 4. Then I have to double the product. So that would really be plus 4 on the square root of 2x minus 4. And then square the last term, which would be plus 4. And on the right side, we just simply get 3x plus 4. Now, looking for things to combine, notice that the negative 4 plus 4 adds 0. So we have 2x plus 4 on the square root of 2x minus 4 is equal to 3x plus 4. Isolating now this radical expression gives us 4 on the square root of 2x minus 4 is equal to just x plus 4. Right, because I needed to subtract the 2x from both sides. So now we can square both sides. It's okay if we have a coefficient, we just have to square that as well. So we would get 16 times 2x minus 4 is equal to x squared plus 8x plus 16. So distributing gives us 32x minus 64 is equal to x squared plus 8x plus 16. So again, we have a quadratic equation. We set one side to 0, so if we subtract 32x from 8x, we get minus 24x. If we add 64 to 16, we get plus 80. So now we need to find what are the factors of 80 whose sum is 24. And the factors of 80 whose sum is 24 would be, what, 20 and 4? The signs are the same, they're both negative. So that tells me that either x minus 20 is equal to 0 or x minus 4 is equal to 0. So our two solutions are 20 and 4. Though I can't really just stop there, right? I've got to check. Do those work? If I plug in the 20, let's see if we can talk this through. 2 times 20 is 40. 40 minus 4 is 36. And the square root of 36 is 6. And 6 plus 2 is 8. So if we plug in 20 on the left, we get 8. Let's see what happens on the right. 3 times 20 is 60. 60 plus 4 is 64. And the square root of 64 is 8. So 20 actually checks in the equation. If we plug in 4, 2 times 4 is 8. 8 minus 4 is 4. The square root of 4 is 2, and 2 plus 2 is 4. Now if we plug 4 in on the right, 3 times 4 is 12, plus 4 is 16. The square root of 16 is 4, so we get 4 equals 4, so that checks as well. So our possible solutions both check to give us 4 and 20 are the solution set. Now let's talk about solving part B, the inequality. To solve the inequality, we've got to consider the domain of the square root of 2x minus 4, which is where 2x minus 4 has to be greater than or equal to 0, or where 2x is greater than or equal to 4, or x is greater than or equal to 2. We've also got to consider the domain of the square root of 3x plus 4, which gives us where 3x is greater than or equal to negative 4, or x is greater than or equal to negative 4/3. Okay, so the intersection, which piece contains both sets, would be x is greater than or equal to 2. So on the graph of the number line, we don't do the whole number line, we just do the values that are greater than or equal to 2. And now we can place our solutions of 4 and 20. So we've got 3 regions to test. So if we plug in a value from region A, which would be 3, we would have is the square root of 2 times 3 minus 4 plus 2. Is that greater than the square root of 3 times 3 plus 4? So what is that? 6 minus 4 would be 2. The square root of 2 is 1.4. Plus 2 is 3.4. And you can use your calculator as much as you need to on this. On the right would be the square root of 9 plus 4, the square root of 13. And the square root of 13 is 3.6. So notice that the first part is false. In region B, I need a number between 4 and 20, so maybe 10. It's 2 times 10 minus 4 plus 2. Is that greater than the square root of 3 times 10 plus 4? So what is that? 20 minus 4 is 16. Oh good, we know that one. The square root of 16 is 4. 4 plus 2 is 6. On the right we get, what, 30 plus 4 is the square root of 34. Well, the square root of 34 is less than 6. We know that, right? It is 5.8. So 6 is greater than 5.8, so that's true. And then a number out of region C, so maybe we plug in 25. 2 times 25 minus 4 and the square root, and then plus 2. Is that greater than the square root of 3 times 25 plus 4? So let's see what we get here. That would be what? 50 minus 4 is 46. And what is the square root of 46? 6.78. When we add 2, we get 8.78. And what do we get on the right? That's what? 75 plus 4 is 79, and the square root of 79 is 8.88. So that would be false. So our solutions occur in region B. And what about the endpoints? Can we include those? No, because we're strictly greater than. So our solution to that would be the interval from 4 to 20. Okay. The last page, I really just wanted to talk about the last few, 35, 36, and 37, when you have the cube root. If you have the cube root, you're going to just cube both sides. So when you cube both sides, the cube root of x plus 1 cubed is just simply x plus 1. Negative 3 cubed would be negative 27. So if we subtract 1, we get negative 28. These you don't really have to check because they're defined for all real numbers, but the cube root, if I plug in negative 27 plus 1, I get negative, if I plug in negative 28 plus 1, I get negative 27. The cube root of negative 27 is negative 3, so I know that works. For the cube root of x plus 5 equals 4, I've got to isolate the cube root first. So if I subtract the 5, I get negative 1. And then we can cube both sides. And the cube root of x cubed is just x equals negative 1. And so that would also check. If I cube both sides here, I would simply get that x plus 1 equals 2x minus 1, and I can subtract x to get x equals, we add 1, we get 2. And that would be the solution. Okay, so stay tuned for the next video on applications. If you have any questions on equations and inequalities, don't hesitate to contact me. Thanks.